Okay, so welcome to the first video of our second unit. Building off what we talked in class about today, I want to talk about a concept called domain, right? And its kind of partner range, okay? So we've already talked a bit about really what domain and range are, but let's see if I can just define it a little more clearly here. So we've talked about an independent variable, and we've talked about this idea of an input, okay? Now, and we always said those are usually the x values. And, in Algebra 1, instead of using x values or independent variable, we're usually going to call it domain, right? So we'll say that a function has a domain. A dependent variable, okay, is also known as an output. And usually is the y values. And then in Algebra 1, we're just going to get used to calling it a range. Okay, so, if we are given a graph, right, and we really think about this situation, we should be able to find its domain. So here we have a leaking water tank, right? And we see as the minutes increase, okay, the gallons go down. So my domain here, right? Well, I know that it's going to be the minutes, right? And I think we have to now identify like what are all possible x values here, right? So we see that it starts at 0 minutes. And then as time goes by, right, it takes 5 minutes for this tank to empty. Now, the idea here is that at each x value, right? So, imagine that we have an x value here of 1/2, right? Well, that x value has a y value of, it looks like about 80 something, right? Or, imagine we have an x value of 3.8, right? And I'm just making up numbers here. We've got a y value that looks like it's about 40. So the idea is for every single x value, we've got a y value that matches it. So every x value from 0 to 5 is in the domain. So the way that we're going to write this is 0 is our smallest x value, and then the x's are all between 0 and 5. Okay, so every x value is between 0 and 5. Okay, and I can think, this says 0 is less than x unless x is less than or equal to 5, right? So I think of this as between 0 and 5, okay? Between 0 and 5 minutes, right? My range, though, is going to be, we're going to measure it in gallons, right? And the gallons, right? So every single y value between 100 and 0 has an x value. Okay, so every value between 0 and 100 is part of my range, right? And since they're the y values, I'm going to write a very similar expression. And I'm going to say that the y's have to be between 0 and 100, right? And knowing that these are measured in gallons. Okay, so now I want to think about a slightly different situation. So we're going to take, now we're stacking textbooks, right? So you can imagine that we've got a floor here, and we're stacking, here's one textbook, here's a second textbook, and we're going to keep going until some unknown point, right? And what we see here is as I stack more and more textbooks, the height keeps increasing, okay? So the domain, right, the independent variable, I can see from my graph here is the number of books, okay? So the domain is the number of books, right? And I see that, now this is a little bit different, right? Because take a value of, say, 1.5, right? 1.5. right? There is no y value that goes with it, right? And logically, this makes sense, right? As I go up and up, I'm never going to hit the graph. And the reason is because I can't have a textbook and a half. I can't take one of these textbooks, cut it in two, and put it in my stack. Okay, so my domain here, well, it's going to be all the possible numbers of books. So 1, 2, 3, 4, 5, and then it looks like I've got a 6 and 7 as well. Okay, so we have to be careful with this, that we don't start to identify numbers that aren't there, right? Same idea with the range. Okay, as I do this, I can't have range values that are, say, between 6 and 8, right? I only have 2 centimeters, 4 centimeters, 6 centimeters, all the way up to 14 centimeters. So my range here is just 2, 4, 6, 8. I'm just going to keep going to 14. 10, 12, and 14. Okay? And the range was the height. Oop. Okay? So that's the basic idea behind identifying domain and range. We're going to take a short break, and then we'll jump in with the second part of the video. Okay, so welcome back to the second part of our video. Now we're going to turn to our second topic, which is function notation, right? And we talked about this in class today, but the basic idea is if you're given a function, right? So we've got a function of x, okay? So it tells us that, this is our domain, right? Our domain is going to be a number, okay? So to get our range, we're going to do 2 times x minus 3, right? So if x is 5, this is, not so bad, right? Now instead of x, whatever goes in here, right? Or whatever goes inside of these parentheses is going to be substituted for x, right? So this is 2 times 5 minus 3, okay? 2 times 5 is 10, minus 3 is 7. So we say that f of 5 is 7. Okay, f of negative 3, same idea. 2 times negative 3 minus 3. So 2 times negative 3 gives me negative 6. I take away 3 more, I get negative 9. Okay? So what we would say here is that f of negative 3 is negative 9. All right? In other words, when we were at negative 3 in our domain, right, we put it into that function machine called f here, and f turned it into negative 9, which is part of our range, okay? Same idea, right? Like let's say that we put in now, and I'm going to use a different color, we put in a 5, right? We put our 5 into the function machine. We did a 2 times 5 minus 3, right? We did 2 times 5 minus 3, and that turned us into a 7. Okay. So we can have a function on 2 variables, right? So now instead of just g of x, we have a g of an x and a y. And it says if you're given an x and a y, you're going to do this. You're going to do an x squared plus a 2y. So 4 and 1, right, is just going to be 4 squared, right? X becomes a 4. And then where I have a y, I'm going to put in a 1, right? And I know that the x is 4 because x is listed first here, right? So x turns into 4, y turns into 1, right? And this is not a complicated idea. It's just a different way of telling us how to substitute. So 4 squared is 16. 2 times 1 is 2. 16 plus 2 is 18. Same thing here, right? Now here, I'm told this 3 here is my, oops, sorry about that, guys. This is my x. I am having a lot of trouble with that today. And this is my y, right? So I do my x squared, which is 3 squared, plus 2 times y, so 2 times 2, right? 3 squared is 9, 2 times 2 is 4, I add those, I get 13. Okay? So, there are more complicated things that we can do by setting up a function like this. Now, this function here looks a little bit different, right? So, I'm going to first tell you that it's called a piecewise defined, okay? And that means the function's going to take on different rules at different points. So we read this like this. We say h of x is x plus 2, that comma I'm going to read as an if, okay? If the x is less than or equal to 4, all right? Now if, and it's going to take on the value 2x if x is greater than 4. So I look at 1, right? And I know right away that 1 is less than or equal to 4. Okay, so I'm going to use the rule, right? I'm going to come around here. I'm going to use this rule that says if x is less than or equal to 4, it's just going to be x, which is 1, plus 2 is 3. Okay? So now for 4, right? This one's tricky. 4 is less than or equal to 4, so I still use this rule here. 4 plus 2 equals 6. All right, and I can still use that rule because the x was fit this, right? X was less than or equal to 4. In this case, it was equal. Now here, though, this one's a little different. Now I have h of 10. Now I know that 10 is greater than 4. Okay, so that tells me I got to use my bottom rule here, which says do 2, sorry guys, times the x value. Okay, and from here I know the x value is 10, so 2 times 10 is 20. So we'll have a lot of practice during class tomorrow on using function notation, right? But the basic idea here is you just substitute, right? You figure out what x you want, or what x and y, or which rule to use, and you plug it into the rule. And it's not so bad. So thank you for watching. That should set you up to do the homework problems, and I'll see you next time. Thank you.